Greetings everyone. Today we are going to see on the topic regenerative endodontics. Regenerative endodontics by Murray et al. Is defined as a biologically based procedure which is designed to replace damaged structures including dentine and root structures as well as cells of the pulp dentine complex. Regenerative dental procedure have a long way going back to 1952 when Dr. B.W. Herman reported to the application of calcium hydroxide in case of vital pulp amputation. There are two basic terms which are used, that is revascularization and regeneration. The term revascularization was first used by Eva et al. In 2001. Later, revitalization instead of revascularization was proposed because this term was more applicable as the tissue regenerated in the canal space were not only blood cells but also soft and the hard tissues. The term regenerative endodontics was adopted by AAE, that is American Association of Endodontists, in 2007 based on this tissue engineering concept. Basically, the necrosed tooth can be treated in two ways, that is traditional endodontics or regenerative endodontics. We use traditional endodontics in case of immature apex, wherein we go for apexification. In case if the apex is mature, that is a mature apex is present, we go ahead with root canal treatment. And apexification does not lead to thickening of the dentinal walls in case of immature tooth. It is significant amount of tooth structure which is lost from the traditional endodontic treatment. In case of regenerative endodontics, if we have an immature apex, we go ahead with revascularization procedure, and in case if we have a mature apex, we go ahead with stem cell therapy or pulp implantation or scaffold or gene implantation therapy. This helps in revitalization of the pulp space with functional tissue capable of dentine deposition. So this regeneration is basically a triad, that is with the presence of stem cells or progenitor cells, then scaffolds or extracellular matrix, and signaling molecules or growth factors. The cells which are responsible in the triad could be adult stem cells, progenitor, embryonic cells, autogenous, allogenic, cultivated, mobilized or engineered stem cells. The scaffolds are the naturally derived synthetic polymers, inorganic materials or foams, fibers, gels, membranes or mesh. The signals could be transforming growth factor beta, bone morphogenic proteins, fibroblastic growth factors, WNTs and tumor necrosing growth factors. Let's look into the triad one by one. First one, the stem cells. The adult dental stem cells can be classified into two, epithelial stem cells and mesenchymal stem cells. The mesenchymal stem cells are derived from 6 different sources. That is, it could be derived from the stem cells of human exfoliated deciduous teeth. It could be derived from dental adult pulp stem cells, the stem cells from the apical part of the papilla, which is the scap cells, the stem cells from the dentin follicles, the periodontal ligament stem cells and bone marrow derived mesenchymal stem cells. Coming to scaffold. Scaffolds are basically an artificial structure which is capable of supporting these cells which are implanted into it in a 3-dimensional tissue formation. The scaffolds basically serve the following purposes, which is it allows cells attachment and migration, it delivers and retains cells and biomechanical factors, it enables diffusion of vital cell nutrients and express products, it provides structural support and shape to the construct. The scaffolds can be further classified as degradable of matrices based on foams, based on presence or absence of cells. Based on its origin, it can be either natural or synthetic or artificial. Based on degradability, it is biodegradable or permanent. Based on form, it is solid blocks, sheets or porous sponges or even hydrogels, which is injectable scaffolds. Based on the presence or absence of the cells, it could be cell-free scaffold or already self-seeded stem cell presence scaffolds. Based on the origin, it could be biological or natural, which is PRP, platelet-rich plasma and platelet-rich fibrin, collagen, chitosin, then demineralized or native dentin matrix, even blood clot and silk. In case of artificial, it could be polymers or bioceramics. The polymers are PLA, PGA, PLGA and PCl, and the bioceramics could be calcium, phosphate, bioactive glasses and glass ceramics. Next is the growth factors. Now that we have the cells which is seeded in the scaffold, there is something which we need like a water for it to promote. So these growth factors come into the role play. So the growth factors are basically the platelet derived growth factors, bone morphogenic proteins, transforming growth factor beta, vascular endothelial growth factor, the fibroblast growth factors, insulin growth factors, nerve growth factors and stromal cell derived growth factors. So these are biological factors which regulate the stem cells to form the desired cell type. So as I told you, the platelet derived growth factors are responsible for cell growth or new generation or repair of blood vessels and collagen production. The vascular endothelial growth factors are the factors which help in the promotion of angiogenesis and wound healing. The epidermal growth factors are helps in the promotion of epithelial stem cells, angiogenesis and also wound healing. The fibroblast growth factors which are present in the epithelialization phases of wound healing, and keratinocytes which cover the wound and performing epithelium. The insulin like growth factors help in cell regulation, cell growth